atoms in your body, the nitrogen, the iron, the carbon, all these elements are not only fundamental to your very existence but are also traceable to a cosmic crucible deep within the cores of stars. Every particle that makes up your being is connected to an ancient, star-studded history. If you were to ask a physicist or cosmologist about the origins of the cosmos, they would likely direct you to intricate equations and detailed theories that explore the Big Bang, the event that gave birth to everything. This scientific theory has been refined over decades, offering a plausible explanation of how our vast universe began its journey into existence. Yet, in recent years, the launch of the James Webb Space Telescope, JWST, has shaken our understanding. With its unparalleled capabilities, the JWST has unveiled astonishing revelations that raise serious questions about the conventional timeline of the cosmos' origins. Its discoveries are turning the world of astrophysics on its head and hinting at a much more complex and dynamic history than we ever imagined. So, what exactly has the James Webb Space Telescope uncovered, and how are these findings reshaping our understanding of the Big Bang? To put things in perspective, as we stand here on Earth, it's easy to feel small and insignificant in the face of the vast universe. But now, thanks to the marvels of modern science and technology, we know that the same atomic building blocks that make up us are the same building blocks, scattered throughout the cosmos. When we peer through telescopes like the JWST, we don't just see stars and galaxies, we glimpse into the very depths of time. Each observation brings us closer to understanding the origins of the universe, and in the process, we unravel mysteries that were once far beyond our reach. JWST's ability to peer back in time, especially through its unmatched infrared vision, has led to groundbreaking discoveries. For instance, the very galaxies we once thought formed slowly and methodically after the Big Bang are now showing signs of having formed much quicker than we ever anticipated. These revelations have left scientists stunned, and they're prompting a re-examination of what we thought we knew about how galaxies, and by extension, the universe itself, came to be. What makes these discoveries even more astonishing is that JWST's capabilities are now allowing us to see galaxies at distances previously thought to be unattainable. Far-off galaxies that were thought to be too faint, too distant to observe, are now coming into view in sharp detail. JWST has unveiled galaxies that seem to have formed not billions, but only hundreds of millions of years after the Big Bang, suggesting a much quicker and more dynamic early universe than the models predicted. One key question arises: is the incredible distance between these galaxies truly as extraordinary as it seems? So far, the answer is a resounding yes. An astronomer named Steven Finkelstein from the University of Texas at Austin has been instrumental in confirming that the majority of these early galaxies do, in fact, exist at the extreme distances we're seeing. His research suggests that the cosmos was far more efficient at creating stars at a young age than we ever imagined. The JWST, launched in December 2021, underwent 6 months of commissioning before it finally began sending back full data in July 2022. Almost immediately, the telescope's powerful infrared sensors began capturing images of galaxies that appeared to be forming just 300 to 400 million years after the Big Bang. This is far earlier than astronomers had expected to observe such phenomena, and the volume of new data has been staggering. These groundbreaking images were initially anticipated to trickle in slowly, but the JWST has defied expectations by delivering a flood of data. The reason behind this rapid discovery lies in a creative shortcut employed by scientists to measure the distances of these galaxies. Instead of using the typical, laborious process of spectroscopy, which involves analyzing the light emitted by galaxies, researchers turned to simpler photometry-based methods. These methods measure fluctuations in a galaxy's brightness to infer its redshift, the way galaxies stretch light as the universe expands. This approach has provided an incredibly efficient way to gather large amounts of data, although the full spectroscopic confirmation is still trickling in.
The data so far has been promising, and several galaxies discovered by the JWST's Advanced Deep Extragalactic Survey, JADES, have confirmed the initial findings. For example, one galaxy with the rather complicated name JADES GSZ 130 has been confirmed to be the most distant object ever observed, seen as it appeared just 320 million years after the Big Bang. This extreme redshift of 13.2 makes it the farthest galaxy known to us, for now. The most exciting part. JWST is poised to shatter this record soon. This new understanding of galaxy formation, where galaxies appear to form much quicker than previously thought, is both awe-inspiring and mind-boggling. As Yale University's Peter Van Dockum aptly put it, we are exploring a period of the cosmos that no human has ever seen before. It's a truly humbling thought to realize that we're peering into the very beginning of everything. But not all of the JWST's discoveries have been straightforward. In one case, Finkelstein's Cosmic Evolution Early Release Science Survey, SEERS, discovered a potential galaxy with an astonishing redshift of 16.4, but subsequent analysis revealed it was a dusty imposter with a much lower redshift of 4.9. While this finding was a disappointment, it highlighted the challenges and uncertainties in this early phase of exploration. Nevertheless, many of the galaxies that JWST has identified continue to hold up to scrutiny. For example, Maisie's galaxy, named after Finkelstein's daughter, was confirmed to have a redshift of 11.4, meaning it existed 400 million years after the Big Bang. These tiny galaxies, much smaller than the Milky Way, are showing extraordinary brightness, likely due to their high rates of star formation. This data has already shifted our understanding of how galaxies form in the early universe. In the past, scientists believed that galaxies didn't begin churning out stars until about 1 billion years after the Big Bang. Now, we're discovering galaxies that are forming stars at an astonishing pace, challenging the notion that the universe was a relatively quiet place in its early years. Despite the incredible findings, these early galaxies don't yet pose a challenge to our leading cosmological models. While they are forming stars more rapidly than we anticipated, they're still not big enough or mature enough to break existing theories. That said, some of these galaxies are smaller than expected but surprisingly massive. These findings may have a profound impact on our understanding of dark matter and how it influences early galaxies. But the discoveries don't stop there. The JWST is uncovering galaxies that are forming stars at a rate up to 1,000 times faster than the Milky Way, a truly mind-blowing discovery that defies our understanding of cosmic processes. As these galaxies continue to be studied, astronomers are grappling with the possibility that we may have missed key mechanisms of star formation in the early universe. Could these galaxies have been formed by unknown processes, or is our understanding of how galaxies evolve in the early universe simply incomplete? Even more jaw-dropping discoveries are on the horizon. Recently, JWST observed a galaxy that existed just 500 million years after the Big Bang. Despite its small size, it is producing stars at a staggering rate, another mystery that defies expectations. This opens up exciting new questions. Is this galaxy a star cluster? Or is it something entirely different? And how is it that such a small galaxy can create stars so quickly? Astronomers are proposing theories to explain these phenomena, from the rapid expansion of supermassive black holes to the possibility of previously undiscovered processes that accelerated star formation. The answer to these questions could completely revolutionize our understanding of how galaxies form. But there's an even bigger mystery at play. Nobel laureate Roger Penrose has suggested that black holes from a prior universe could have accelerated the expansion of our cosmos, a theory that's gaining traction thanks to JWST's findings. The telescope's recent discoveries seem to support this idea, as they show galaxies and black holes in stages of formation far earlier than we expected.
Penrose's cyclic universe theory, which proposes an eternal cycle of universes born from each other, could hold the key to understanding the origins of the cosmos. If this theory proves true, it would fundamentally change everything we know about the birth of the universe. JWST's ability to peer into the deepest corners of space and time is allowing us to glimpse the universe's past in ways we never thought possible. As new discoveries come to light, scientists are increasingly confident that we are on the brink of unveiling the greatest mysteries of our existence. In the end, the James Webb Space Telescope is not just a tool for observing the distant universe. It's an instrument that's challenging the very foundations of our understanding. Every new discovery brings with it more questions, and perhaps that's the most exciting part of all. Who knows how far we will be able to see in the future? Perhaps the formation of galaxies began even earlier than we thought, at a redshift of 20, just 180 million years after the Big Bang. For now, JWST has taught us one thing: to expect the unexpected.